The Harvard Business Review said that data scientist was the sexiest job of the 21st century. But the reality is, there are countless cool jobs in data these days. From analysts and engineers to architects and storytellers, across all industries, data professionals are making the grade. That's even true for formerly mundane tasks like backup and security. Find out more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanagh, here with a couple rock stars in the data world, folks. We're going to talk about a very fun topic, and that is cool jobs in data. And there are lots and lots of cool jobs in data these days. A few years ago, I think it was the New York Times that said data scientist is the sexiest job to have. And these days, there are lots of very cool jobs that you can have. And part of the reason is because a lot of the blocking and tackling of traditional data management is now largely handled for you. Certainly, if it's in the cloud, a lot of that stuff is taken care of for you, but even on-prem, a lot of the tools and technologies have taken care of some of the hard stuff, the grittier things that you have typically had to worry about over the years. And so now you can do more of the value-added stuff, more of the interesting things, finding patterns in the data, troubleshooting, problem solving, doing the cool stuff that makes you feel good and have fun. And that's what we're going to talk about today. So we've got Joe Gasca. He is the CEO of a company called Grax. He's been around the business for a while. And we've got Stephen Manley from a company called Druva. He's the CTO over there. So let's just kind of dive in and introduce ourselves. Joe, I'll throw it over to you first. You've been in the data space for a while now. And of course, Grax is focused heavily on the Salesforce world, but you're all about capturing signal too. So tell me a bit about yourself and Grax and what you guys are working on these days.
Yeah, great, Eric. Thanks a lot. So Grax is a data lifecycle management focused specifically on Salesforce. And like you said, data itself is really starting to become very sexy again, right? When you really think about, the full life cycle of any data creates data, right? So when we hyper-focused on Salesforce, specifically if it's backup, if it's archive, if it's restore, you think of those tactical obligations that you have with data, right? How do I protect it? How do I recover from it? But also having every version of data has really interesting possibilities when you start looking for signals and variants and trends and anomalies. Not just saying that, hey, did something bad happen? But what are the opportunities and strategic advantages with the data itself and the history? And that's really where we've been hyper-focused on. What is your data? What does your data history tell you? And what is the trends of your data itself? And that's really where some very interesting things are happening.
Yeah, and just to get our other guest in the early stages here, I'll throw it over to Stephen Manley from a company called Druva. I've been following those guys for a number of years now, doing some very interesting work as well. Just tell us quickly about yourself and Druva, and you've got a recent announcement you're talking about too. Go ahead.
Yeah, so I'm CTO here at Druva. Been here for about 5 years or so. Spent most of my life protecting people's data. And Druva, you can think of us as a SaaS company that secures and protects data for our customers. So to Joe's point, they're very Salesforce focused. We're focused on everything. You've got data all over the place, whether it's in Microsoft 365 or your data center, or your endpoints or remote offices. We want to protect and secure it all for you. And in addition to having all those versions and being able to recover and all the fundamentals that Joe talked about, we're also super passionate about the metadata, right? What can I learn by understanding what's happening to your data over time, and what kind of things can we expose to you? And so, like you said, we have a big announcement. We just launched what we call Drew Investigate, which is a Gen AI, we call it a co-pilot that really helps companies that are worried about, am I under some sort of cyber attack, some sort of ransomware attack, really helping guide them towards understanding what administrators could have been compromised, what data, what systems could have been compromised, and using that metadata we've got access to again, get them to the right answer faster, because the faster you respond, the faster you recover, the faster you're back up and running and doing cool stuff with your data again.
Yeah, that's interesting. And real quick, talk about the Gen AI side of that. Are you using Gen AI to articulate text that explains what the systems are doing? Is that kind of the use case there?
Yeah, so it's sort of a multi-layered cake of Gen AI. So one of the things that we've found as we've gotten into this Gen AI space is that everybody sort of goes, well, all right, it's a chatbot. And that's the top layer of the cake, right? A natural language interface so you can, again, if you're not an expert in using Druva or Grax or whatever tool you want, it's a natural language interface. So that's the top layer of the cake. But then there's other layers of the cake behind it because you need something that's going to be able to translate that natural language into, well, what problem are you looking to solve? Are you worried about, sort of administrators that have gone rogue or been compromised? Are you worried about whether your Microsoft 365 environment just suddenly has a bunch of encrypted data? So you need that second layer of Gen AI to really interpret what the customer is asking. And then the third layer of the cake is then connecting to the backend metadata and saying, well, look, we've seen thousands of ransomware events through the years. We can understand from your question and what's happening, this is the area you need to be looking. And so with the Gen AI space, if you've just got that natural language interface, it's good. But if you can actually start to correlate the information with the history, that's when you start to really get some interesting conclusions. And it's not just a search or a natural language interface. It's actually helping you drive your investigation because it's that expert that's sitting on your shoulder saying, this is where you should be looking right now.
Yeah, I think that's a really interesting similarity between what Druva is doing and what Grax is doing, because to your point a moment ago, Joe, I'll throw it back over to you. Grax has been focused on this data lifecycle management, which is very important to understand where we've come from, where we're going. You can't tell where you're going if you don't know where you came from, right? Because it's all part of a trajectory. And you figured out a long time ago that you want to allow your customers to have knobs they can turn about just how granular of data they want to capture. But you want to be able to capture everything. And Salesforce, let's face it, Salesforce is a juggernaut. It's kind of the poster child for software as a service. They've been around forever and a day. Of course, Mark Benioff, very, very smart businessman. They bought Tableau, they bought Slack, they bought all kinds of other things, and now they are a huge center of gravity into themselves. And of course, Salesforce is focused on, wait for it, sales. And no company succeeds without making money somehow. You get investment, but then you have to go buy, get people to buy your technology and your software. So maybe talk, Joe, about the importance of having that history, being able to detect signal over time, and maybe give us some examples of what you're able to do for your clients.
Sure, absolutely. So just like Stephen was saying, but the one key thing, I think that's the commonality between everything, is protecting your history and owning your history as a company is both tactically and strategically important. We all know this. And the one thing I know that Druva and we have been focused on is you have to eliminate the single vendor risk, right? Salesforce, even buying own backup and having your backups being owned by Salesforce, that is single vendor risk. And a lot of companies that are looking out saying, not only do I want to protect, but I need to own my history, either from audit, compliance, and regulatory reasons that you can govern all of that. But the history itself, much like what Stephen was saying, is there's a lot of very interesting things that you can learn from your history, right? Whether it's pattern recognition, whether it's reacting to an event that is causing you adverse event from security, or whether it's reacting to sales more efficiently. The one thing commonality between a lot of our companies that are going out there and really saying and preaching the word, because we understand how valuable history is. And the one thing that we're working hard for is to make sure our customers are protected. Customers are protected for having the optionality in the future of owning your history, making sure that you can make meaningful decisions from your history is critical. So the one thing that we've been hyper-focused on, I know Druva is very, very similar to us, is basically capture history, protect it. If you need it, you have that optionality. And that's the key piece right now, is really thinking ahead as AI and machine learning is evolving. And we know 3, 5, 10 years out from now, the technologies, the leaders, all the capabilities from Azure, GCP, AWS, they're all going to evolve with new technologies, new capabilities, being locked into a single ecosystem where you can use that history. That really was where the problems come in. And that's one thing that we've been hyper-focused on, is saying, listen, Salesforce has one version of data. As soon as you deploy Grax, we have every single version of data, every single version of metadata, every single version of files, attachments, binary streams, everything, every single piece of data that you possibly need. But here's where it gets really interesting, and I'm sure Stephen is running into this as well, is, okay, now that you have the history, and we are just evolving, much like Druva is, much like everyone saying, wow, Moore's law is driving down the cost of storage. So it's no longer cost prohibitive to store mass amounts of data when petabytes cost, hundreds of dollars. And Salesforce is charging 10,000% more than what basic blob storage costs. Wow. Really having that optionality and saying, okay, now that I have my data, and this is where we said really cool jobs come up. We all know that between historical data, as Stephen referred to it, metadata. When a record changes from one value to another, what was the duration? What was the time? What was it before it? All of that metadata about those changes are really what starts to feed power, anomaly detection, signal variance detection. That's really where the very interesting things come. And really, when you're getting it to start, quant-driven decision making, you have to get a lot of patterns and you have to get a lot of history to back test some of these theories, some of these algorithms.
Right.
And without the source of truth, without your base raw history, and without protecting that history, you're really locked in and you're really handcuffed to using one AI model. So we focus on Salesforce, and of course, Salesforce, amazing technology, love working with them, great partnerships. And they are going out with a lot of their AI patterns. But we see a lot of companies right now, they don't want to just use one piece of AI technology. They want to use them all. And they want the optionality of doing that. So we're hyper-focusing on protecting the data, protect optionality for our customers. We're trying to add value as quickly as we can to that data. And that comes from everything from, as Stephen was alluding to, risk mitigation for if something happens. There's also optionality that we're focusing on is based on pattern recognition for driving revenue or service metrics. Are you at risk for customer attrition? All of that data exists within your history. And that's really where it comes from, cool data jobs. People that have that overlap, the mathematical and analytical mind with understanding data, schema, and history. There's a weird intersection there where people having the quant-driven mindset, understanding data and schema and historical data over time, that's really where you can start getting into how can I build these models. That's when it comes some really cool technology and really start building out. And we're just at the, we think AI and machine learning. This is AI and machine learning is the equivalent of the internet back in the late 90s. Mm-hmm. We're just at the beginning.
I think you're right, and you bring up a really good point. I'll have you comment, and then we'll bring Stephen back in to comment on this. AI loves the gritty, granular details. It doesn't want roll-ups like you would see in a dashboard, for example. It wants that real gritty detail that's trapped in all these various systems. And so by capturing your whole history, Joe, what you're enabling is all sorts of multivariate views of relationships between entities. So it could be uptime versus traffic versus personnel involved in a particular task. It could be any number of things that you don't know about. And what's so cool about these models, when you start training them and using them, is they pick up stuff that you just were not going to see. I mean, it's like, I think I always joke that training a model is like raising a kid. You got to be careful what you expose them to, right? Because they'll just absorb stuff and then it reflects right back at you. And you're like, oh no, I shouldn't have said that in front of my kid. Like if you talk trash about your neighbor, they're like, Daddy says you're a jerk. I'm like, oh no, like there it goes. So you got to be careful about what you go in there. But if it's just transactional data from Salesforce, that's all grist for the mill, right? What do you think, Joe?
So you're 100% right. And I'll tell you kind of an interesting story that when you think about it after the moment, you're going, aha. Like, so if you capture everything from Salesforce, right? System tables, data tables, opportunities, and you said there's indirect correlations between outcomes. That's basically what my mind is going to. And what we're saying is, now think about it. If you have IP logs from where people log in and you can track the effectiveness of your employees with closing deals, you can find an indirect correlation between the effectiveness of your employees closing deals relative to where they're actually logging in from. If I'm going down to the islands and I'm working remotely, but I'm working 4 hours a day and all of a sudden my output dropped, from all of your data, if you really feed them into some of these models, you can find indirect correlations between data that you never assumed. But without your complete history, because this is where it comes in very interesting. People used to pick and choose data. I want to back up this data or this data or this data.
Right.
You're getting part of the story, not all the story.
We were just talking about AI models. Very, very interesting stuff. As Joe had mentioned, we're very early days in this right now. This is definitely a new wave of innovation that we're seeing. And there's a lot of R&D that's gone into this. There's a lot of time that has to be spent in understanding what these things do. I mean, one of my good buddies in the industry, Dr. Usama Fayyad, he heads up the Institute for Experiential AI out of Northeastern University, I think, in Massachusetts. And he joked to me at the beginning of the year, he said, these models, they're too big. They're not supposed to work. We don't know why they're working. And this guy is an AI expert, okay? He was the first chief data officer from Yahoo. And he's saying, yeah, it's not supposed to work. Like, he's sort of half joking, but his point is that they are very, very complex and they can actually learn things, right? So the aha moment for me with the Gen AI stuff was realizing that when you train a model on a big corpus of text, it's not actually persisting that text the way you think in the old database world where strings of text persisted exactly as they were delivered. No, what you're doing is adjusting the weights and balances and the parameters of the model, which then can absorb things and learn and do interesting stuff. So there's all this research being done. I'll throw it over to Stephen maybe to talk about this, because you've got this new AI investigator thing, which sounds like it fits into this world. But the point is, if you get the right model, you can slap it on top of a big, large data set and get answers very, very quickly in a much different dynamic than we're accustomed to doing. So there is a mindset change that has to happen here as people explore, but they are probabilistic. So you always have to keep that in mind. These new Gen AI models are probabilistic. They are not deterministic. So there's always going to be a little bit of a gray area you have to watch out for. But Stephen, maybe just comment on that and talk about how your new AI investigator is fitting into this new interesting category.
Yeah, and just to sort of geek out at a low level, just for a minute or two. Everybody out there has probably played with some sort of Gen AI tool, just from a consumer perspective, and they're great, and they're especially great because it's been trained on such a huge corpus of data. And to your point, we don't expect it to be 100% accurate. Now, as you shift into more of a corporate business setting, the thing you notice is, first off, there are fewer and fewer sort of base models, base LLMs than there used to be, because it's getting so expensive to train an LLM.
Right.
And so our viewpoint on this is, the world's going to end up with 3 to 5 LLMs, really, and then probably some custom niche ones, but there'll be an anchor of sort of 3 to 5 with different features and functions. And so that's going to be relatively constant. So then the interesting questions start to raise, on all right, how do you train using that model so that you can solve your business problem? And then how do you augment, whether it's through RAGs or through other sorts of technologies, to make sure that you're going to get those accurate answers, you're going to eliminate the hallucinations, and you're going to get the performance your customers expect. And so this is why, certainly when we built Investigate, we used RAG, which is Retrieval Augmented Generation, to help it better understand what happens in a cyber attack, right? Mm-hmm. Because when a customer's coming to Drew Investigate, they're not coming to do their homework, right? This isn't to find out who won the World Series 7 years ago. They're trying to figure out, am I under attack? What are my next steps? And so the RAG really helps keep it focused. Now, the second thing that we see happening is, as the amount of data you feed in gets bigger, because this is where Joe was going, the more data, the more good data, the better off you are, the more you want to be able to express those relationships. How does it relate? Because your database analogy is apt. It's not like this is all predefined. Right. We want to find these relationships. And so we view, sort of having a graph infrastructure underneath that allows you to dynamically assess what the relationships between the data are, really helps you when you're looking for, in our case especially, anomalous behavior. Mm-hmm. Joe over here is suddenly doing adjusting backup policies from Costa Rica, which is interesting because Joe's never been to Costa Rica and Joe's never adjusted a backup policy in his life. The fact that he's doing both at the same time is really weird. There's a good chance that Joe's account has been compromised. So these sorts of things happen when you start to be able to build out those full relationships. And so, the baseline is great. And there's going to be those 3 to 5 models that just keep getting enhanced. But the value is going to be what you build on top of it, because that's where the real magic is going to happen in the next 3 years.
Yeah, that's very interesting. And I think RAG is going to be a part of our future. I don't think it's ever going to go away. And I think, frankly, that many software vendors are going to need to figure out where they fit in this new RAG architecture, because I view it as being as significant a transformation as we saw with Kubernetes. Because Kubernetes comes along, Docker first, of course, containerization, Kubernetes kind of rode as like piggybacked on top of that and has now taken over. I mean, Kubernetes arguably won that whole game. And it was a massive transformation. You had to refactor your deck to work, your stack to work in this new containerized world. And I think similar thing is happening here with this Gen AI stuff. And people are gonna have to refactor and refocus their attention on how are we gonna fit in this new world and what is our value add gonna be. And Joe, I'll throw it over to you from Grax. I remember you talking about how you folks made good decisions a number of years ago, and that's starting to really pay off. And one of those decisions that really caught my attention was Parquet, that you glommed on to Parquet as a file format, because you're like, you know what, this is going to be big in the future because it's custom designed to facilitate analytics. And now you see that everywhere. See everyone jumping on the Parquet bandwagon. Guess what? It's a de facto standard now. And because you placed that bet, you positioned yourselves very well. Maybe just kind of comment on all that.
Yeah, I mean, if you think about, I mean, it's basically large data structures, and what's the highest concentration for analytics or data tools for consumption purposes, right? So our data lake itself, when we output it for consumption, we optimized it to optimize the optionality of end consuming of that Parquet data. Our data structure itself is basically a huge graph database and how they interrelationships, but we output it in Parquet for easy and quick consumption for optionality in the future. Right, a lot of things that everyone's talking about today, and really thinking about, when we think about LLMs, we think about graph and graph theory, right? A lot of these have been around since the 1950s, right? Shortest path algorithms from, what's his name, Dijkstra, right, in the 50s, but it wasn't possibility for until compute kind of caught up to where it is. So a lot of these patterns and a lot of these algorithms have existed for a long time, and a lot of theories that you could put them through and say, large volume compute, GPUs, storage cost is down, storage transmission is down. These capabilities have always existed. So, but if you think about now, because of the economies of scale, and because we can now put this in place where it actually makes sense and put these out there, right, it starts to become incredibly interesting with what problems you can attack. Because we used to think before, Google, right? Google, you could go in, ask a question, get an answer for the web, right? Now we're starting to see LLM come in and say, okay, we're going to ask questions and get the data, right? There's evolutions that are happening now at scale, because now, instead of having this massive cluster that Google could put up, we could actually now put in the compute to actually get down there. So the Parquet piece that we really hyper focused on in the bets, there's a few key bets that we made beliefs that were different. We believed in bring your own cloud, customers should always own. Our distribution methodology was almost like a distributed compute mechanism. So we have a massive distributed compute cluster that is actually distributed across everybody's cloud. They can have singular models that actually get distributed to the clouds and processed there. But the Parquet piece is 100% correct. We bet on Parquet just because when we started thinking about optionality and protecting your history and reusability for your customers, we have to make sure we protect what's best for the customers. And that is, okay, you have your history, you have the optionality to reuse your history. You're not locked into one singular ecosystem, whether it's Tableau, QuickSight, Power BI, or Snowflake or any of the tools. All of our customers have all the tools.
Yeah, right.
And it's tough to say who's going to win. Like I said, the birth of the beginning of kind of AI and machine learning really at scale is beginning. The theory has always been here, but the beginning of the journey, when you said the first Ethernet was what? was it the late 70s? Birth of the
Yeah.
internet, kind of the mid 90s, right around there. All of that's because Moore's law and getting cheaper and actually going up. When you really start thinking about this, it's really exciting for me. I'm a data nerd at heart. I love this stuff. The more data, the more possibilities. As compute gets cheaper, we throw more at it, more models, but we're just learning from it. It's
Right.
great. I love this stuff.
Right. No, this is good stuff. And, I'll throw it over to Stephen to comment on. We talked about the history and the optionality. One of the key components of building a model and understanding data is knowing the timestamps. What window of activity do I want to monitor to understand something? Is it a second? Is it a minute? Is it an hour? Is it a day? It depends on the use case. But when you're engaged in a stochastic process of trying to understand something and discover, which is a lot of what is done in the Druva world, right? You're investigating, you're looking for answers, just being showered with data points from every different direction, and you never know where that covariance is going to come from. That's why you want the optionality to be able to test this theory and that theory and do so quickly, and then prove it out, right? So that's why it's so important to have this history, to have this richness, and have the capacity to choose your markers and how you cordon off the data to analyze it. What do you think?
Yeah, no, and I think a lot of people have heard this stat, but it remains true. The average dwell time at this point for a cyber attack is about 6 months. So
That's crazy.
if you're looking just back 2 weeks, I mean, you'll find stuff in the last 2 weeks. That's one thing usually when it's gone really bad. But in terms of if you really want to sort of diagnose when things started going wrong, when attacks started moving laterally, you're going to want a longer history of data than most security teams keep. And that's because it's expensive for them to keep. Like Joe said, the markup on that storage, you look at how expensive it can be to store those logs. Well, in a lot of these tools, it's incredibly expensive. And so this is one of the things that as Druva, we look and we say, if there's one thing we're really good at effectively and inexpensively storing a lot of data for you. And then when you need to get at it, we're really good at bringing it back and feeding it into whatever tool, whatever infrastructure you want to use, so you have it when you need it. And I think to me, that's probably the biggest thing, because I think one of the interesting things that I talk about with customers a lot is, we have that same sort of Google search to sort of, we call it ChatGPT sort of analogy. And one of the things I remind them is that while Google was always wildly successful from a consumer, sort of broad internet perspective, organizations, we all continue to struggle with sort of search inside of the enterprise because again, the challenge you've got is there's not enough data, there's not enough to be able to really train it up the way Google was able to train across the massive corpus of the internet. And that same thing is going to be true as you try to do analytics or use generative AI inside of your organization. If you're trying to do it in a complete silo and do it all on your own, it's going to be hard. And so you need to sort of attach yourself to, again, a larger collective, a broader perspective, because these things work better when you're at scale. And so this is what we always try to remind people is, the more you can be part of a bigger picture, the more you've got bringing in, the better the results you're going to be able to get.